Hello students, now we are going to start the second part of the topic as SFD and BMD. So it's a continuation class rather you can say. So our first topic under this support and reactions. So here you can see as the first one is indicating the supports, as there are three kinds of supports are there. One is fixed support, then pin support and the roller support. The next is representing as how it used to represent it. That means the next is how the supports are being represented. That's why representations. So it is the representation of the fixed support. This is the representation of the pin support, and that way we used to represent the roller support. The third one is indicating the reactions. That means the reactions comes because of these supports. So whenever there is any fixed support as like this or that, then you can see there will be reaction in the vertical direction, there will be reaction in the horizontal direction, and there will be movement. Because if it's subjected to a load in the downward directions, it causes to move your beam in the clockwise. That's why there will be a generation of a moment in anti-clockwise direction. Clear? So because of this kind of fixed support, we used to see the reaction in that manner as the vertical directions, as the horizontal direction, as well as the movement. Now move to the second kind. If we go with the pin support, then it also again known as hinge support. So from that point, which indicates this point actually. So from that point you can see there will be generation of a reaction force in the vertical direction. There is a generation of reaction force in the horizontal direction, but there is no movement. That means we actually allow the movement across this axis. Rather, we can say the movement is being allowed, so it's not restricted. In case of roller support, you can see we are getting only a reaction in the down upward direction. Clear? There is no reaction in the horizontal direction. There is no movement. Clear? So we can say the movement as well as the horizontal direction force is not restricted. Rather, we allowed it. Clear? So if we trying to understand the supports with respect to the examples or the applications that we can say fixed wall bracket is a kind of example under fixed support, or any door hinge that can be considered to understand the topic pin support. As in case of any door hinge, if we analyze, then you can see it is restricted the movement in the downward direction. It used to move in the horizontal direction, but it allows the movement like this. And regarding the roller support, if you move to any ferrygate bridge, as you can see, as one end of the ferrygate bridge is along with that kind of supports, because it used to allow the horizontal movement, because whenever there is any upliftment in the water level itself in the river, then that causes to move your bridge in the upward or downward direction. Clear? So it used to provide a support, but it the corresponding movement of the water level is being adjusted by moving the roller in the horizontal direction. Clear? So that's all from the support and reaction. Now we move to our next topic. The next topic is on load. So the first one is indicating the types of loads. Then this dotted line is actually trying to indicate how it represented. And the third one is a brief about that. So the first one is point load. As the name suggests, the load that is being represented by capital W. Can you see? And for our convenience, we used to represent all the beams as like a simply supported beam. Okay. And we have already discussed how a simply supported beam looks in the previous session as part 1 of the SFD BMD. So here you can see as load W acted through a point, that is as it represented. The next one is uniformly distributed load. It represents like this and indicated by small w, where the small w is indicating intensity of load, that is load per unit length. Clear? So whenever that kind of problem you are facing as uniformly distributed load, or the next one is UVL, first we are trying to find out the capital W, that is a point load. So first treat any kind of load as a point load, and then where does it act? It always acts from CG. So find out the CG and then try to go for the other purpose or the calculations. So small w is indicating the intensity of load or the load per unit length, that is capital W by L. So first treat it as point load, then acts as CG. Then uniformly varying load, and here we are used to draw two figure because it can be represented two manner. One manner is it can indicate the load is varying from 0 to small w, that is per unit load, per unit length. So for that kind of problem, we used to calculate the W acting or the acting load as equal to half into W into L, or rather the area of the triangle. It should come as W L by 2, small w into L by 2, which obviously acts to the CG of the triangle. Again, it can also be given in that manner as the load is varying from 0 to capital W. at that time the acting load should be average of the total. So it should be 0 plus W by 2. So finally it comes as capital W by 2, which acts again from CG. Now for triangle, as we know from the engineering mechanics subjects, the CG will be located at 1/3 of the distance from base. That means if this, we can consider that triangle, and this is the base, this is the top. So with respect to finding the CG of that triangle, it should be 1/3 from this, from that side. It will be somewhere here. Here. So this is CG. This distance is, we can say, 1/3 of L, and this distance is 2/3 of L. So from base it will be 1/3 of L, and from top it will be 2/3. So from that side it will be 1/3, and from that side it will be 2/3, as it mentioned here. Okay. So that's all from the part 2. Now our next part will be uploaded soon. It will be part 3 considering the SFD BMD. That's all from now.